Hello, my name is Arturo Jaime, and I am a fourth year PhD student in the mathematics department here at the University of Hawaii, Amanoa. First of all, I'd like to thank the ARCS Foundation for granting me this award. I'm very honored and grateful to be receiving this scholarship. A little bit about myself. I'm originally from Phoenix, Arizona, and did my undergraduate there at Arizona State University. And it was there where I was first introduced to fields of math that I would come to love and study, those being operator algebras and algebraic topology. And you can certainly say it was my insistence on not wanting to study one or the other that brought me here to the University of Hawaii, and specifically to study under my advisor, Dr. Rufus Willett. A little bit about the area of research that I work in and study. You can call it non-commutative geometry, you can call it non-commutative topology, but what I really study is sort of the intersection of two fields. One being C-star algebras and operator algebras. This is sort of the field of math that was born from quantum mechanics. And you can think about it as sort of the study of large infinite matrices, but really what it is sort of the study of analysis of certain operators. You can think about it as the bounded operators over a Hilbert space, these being sort of infinite dimensional vector spaces. But some more sort of hands-on examples that you can think of are sort of the n by n matrices over the complex numbers, or sort of the continuous functions over an interval. And these are certainly C-star algebras. And on the other hand, I study algebraic topology. This is the area of math that studies spaces, but specifically the invariance of spaces under continuous transformations, or rather the algebraic invariance and algebraic tools used to study these spaces. And it is at this intersection of these two fields that I work in, specifically the bridge that connects algebraic topology to C-star algebras. Now, they're not the same sides of, or different sides of the same coin, but the bridge that connects these two is certainly powerful and has proved to be very successful. What I specifically do and study in my research is I look and zoom in at these objects. And remember, these are infinite dimensional objects. These could be very large and hard to really work with. So one thing you can do is zoom in and take sort of a finite dimensional picture. I specifically look at this finite dimensional picture and cut it up into well-behaving parts. And the motivation behind that is to emulate something that happens here in algebraic topology and try to see if I can bring that over, see if that sort of tools that were used here translate well to this world of C-star algebras, and see if I can sort of deduce global consequences just from that zoomed in finite dimensional picture. And that, you can say, is sort of what I do. Finite dimensional approximations of the C-star algebras and sort of translating these tools into that context. Thank you for your time.